Okay, so I'll begin now. So today we'll be learning about applying Newton's laws. So first of all, we'll learn about the free body diagrams. So a free body diagram is a picture representation of all the forces acting on an object. We use arrows to represent the forces and indicate the direction and magnitude. Magnitude expressed by a number and arrow in size. So for example, if there's a box on the ground, then the free body diagram would just be all the forces acting on it. So if it's static and it's on the ground, then the only forces acting on it is the weight and the normal force, which would be Fn and W. And since it's static on the ground, then these forces will cancel each other. So there's technically no forces acting on it. So in a free body diagram, these are some of the types of forces that could be in it. So first of all, there's the weight or force of gravity, and that's a downward force. And then there's the applied force. So if there's a box again and you apply a force like that, then it would be force applied. And the weight would be just that way again. The normal force is the force from surface object is on always perpendicular to the surface. So if the surface is right here, then the normal force will be perpendicular to it. So it's going to go up. The friction is exerted by is always opposite of the motion. So since you're applying this force right here, um, so here's a box again. If you're applying a force this way, then the friction would resist against it. So this is the frictional force. The air resistance is a force, a frictional force that's acting upon you when you're traveling through the air. Tension is the force exerted by a rope or cable. So for example, if there's a box and you're pulling it on a rope right here, this way, or I mean this technically, then there would be tension force. And then spring force is just the force exerted by a spring. Okay, so this is a review of Newton's second law. So Newton's second law is force is equal to ma, force being force, m being mass, and a being the acceleration. And force is a vector, so it has direction and magnitude. The total force or net force is equal to all the forces acting on a body. So F net is equal to ma. So it is a box, then you had to count for all the forces in it. So let's go back to other example where it was the box on the ground and it's not moving. So it had the gravitational force and the normal force. So the net force would just be equal to the normal force subtracted by the gravitational force is equal to ma. And since these two are equal, it would just be 0. So the net force would be 0. Okay, so equilibrium. The forces in a system are balanced when F net is equal to 0. The system is not accelerating and velocity is constant. Velocity is 0 when the system is in static equilibrium, and velocity is constant and non-zero when a system is in dynamic equilibrium. So the example I had before was the example of static equilibrium. And a dynamic equilibrium is when a box is moving in a constant acceleration. So yeah. And then we'll talk about weight. So weight is a vector and it's not the same thing as mass. So all right, this is the equation for weight. This is a force related to gravity. So you get it from the original equation, F is equal to ma. And in this case, A is equal to G, or the acceleration due to gravity. So you just rewrite the equation as weight is equal to mg. And apparent weight is the magnitude of supporting contact forces. Okay, so now normal forces. Normal forces are the force from, so basically, normal force is, as I said before, perpendicular to the surface, and it's always going to be opposite from the gravitational force. And now I'll talk about friction. So there's two different kinds of friction. There's static friction and kinetic friction. So static friction is between two or more solid objects that are not moving relative to each other. And kinetic friction force only applies to an object that is moving, and kinetic, and otherwise known as sliding friction. So, and this is the equation you would get, you would use to find the frictional force. So you would have the coefficient of the friction. This could be kinetic or static, and the force could be kinetic or static. And it would be the um the kinetic or the friction coefficient times the normal force, which in most cases would be mg. So now I'll talk about inclined planes. So these are a very common problem that will be used in forces problems. So in a normal inclined plane, it would just look like this, with the angle being here and an object laying on here. So in this case, it's a box. So all the forces are acting on it are, this is the normal force going in this direction, and this is the gravitational force. I mean, it's the perpendicular force, and this is the gravitational force. So let's just say that this is the weight right here. So the weight is mg. So if this is angle theta, then this part would be mg times cosine theta by using trig. And this right here would be mg sine theta, which is direction going in this direction, which is why this part right here is mg sine theta. And then this is the frictional force. So in inclined planes, it would show that the normal force is also equal to mg cosine theta if this box is static. And so these two parts would have to be equal. And it would also mean that this part is equal to mg sine theta. Okay, so you guys can do question 1. Okay, so the solution to this question would be Z. So it asks which following represents a normal force, and in an inclined plane, the normal force is always perpendicular. So it would be this component right here. So it'd be Z. And this is the solution. Okay, so you can do question 2. Okay, so for this question, it asks which of the following is not true. So the first statement is W is equal to mg, and that is just weight, so it would be true. And z is equal to negative y, so it's talking about the normal force and its opposite. So yeah, that would also be true. V is equal to negative W times cosine A. So V is the frictional force and W is the um wait, so we know the equation for frictional force is equal to the coefficient times the normal force, and the normal force is mg cosine theta, or negative mg cosine theta, I guess. So you are missing the coefficient in this one, so this is wrong. And the other ones are right. So x squared times y squared is w squared is Pythagorean theorem, and the angle is just theta. So this is the solution. Okay, so this is question 3. Okay, so this question asks you what is the distance the object travels based on the diagram, and the answer is actually you can't find it because there's not enough information, because you don't even know where the block starts. So it would be probably it wouldn't be possible to find the distance the object travels based on the diagram. So here's the solution. Okay, so I'll give you a few minutes to try question 4. Okay, so for this question, it asked a person who weighs 700 newtons is sitting as on the floor of an lift. The elevator accelerates downwards at 4 meters per second square. What would the scale read? So the way scales work is that it actually tells you the normal force. So in this problem, we're trying to find the normal force. So the equation you would write would be the total force is equal to ma. So the only forces are the gravitational force minus um the normal force is equal to ma. So you're told that a person weighs 700 newtons standing on a scale. So um it would mean that the weight is equal to 700 newtons. So you know the weight and you know the acceleration and you want to find the mass. So Fg is equal to mg. So it would be m times I'll just round g to 10 in this situation. So m would be equal to 70 kg. And then you would just plug in into this equation. So it would be 700 newtons minus the normal force is equal to 70 times 4. So that's 280. So the normal force would be equal to 420 newtons. So it'd be option 2. You guys understand this one? Okay, so you can do question 5. Okay, so for this question, it says a block of wood with mass 1 kg is clamped to a vertical board with a force of 10 newtons. What is the minimum vertical force needed to move the block upwards? So it would look like this, a block of wood here, and there would be a applied force, 10 newtons. The mass is 1 kg. So um there would be two, so basically there would be the normal force and the frictional force. And this is also the weight, trying to make it go down. So it would be this force minus F frictional minus the weight is equal to 0. So it would be force equal to the frictional force plus the weight. And we know the frictional force is equal to the coefficient of friction times the normal force, and weight is equal to mg. So you know both those things. So you're given the static frictional force, friction was 0.15. N is the force of 10, so it's 10 plus 1 times 9.84 g. So this is the solution. And you would get 11.5 newtons. Okay, so you can do question 6.
I want a very long, complicated chart.
Okay, so for this question, it says a 40 kg block is initially sitting at rest on a horizontal floor. So like that. And the mass is given as 40 kg. With the coefficient of static friction of 0.4, a horizontal pushing force is applied to the box. What is the maximum pushing force that can be applied without moving the box? So it's just asking, since the only force acting on it right now is the friction. So since the vertical forces cancel out. So that would be equal to the coefficient of static times normal force, which is 0.4 times normal force. So the normal force in this situation, since it's sitting on a horizontal floor, would be the negative of the weight, which is just negative mg. So, and you're given the mass is 40 kg, and you know g, so it would be negative 40 times 9.8. And then you just plug it into this equation and you get the frictional force. And that would be equal to, oh wait, sorry. Oh, since it's going upwards as well, it would be negative g as well. So it'd be negative 40 times negative 9.8. And then you get 156.8 newtons. So this is the solution. Okay, so this is question 7. Okay, so for this question, it says, given that coefficient of kinetic friction is 0.3, what is the magnitude of the frictional force exerted on the object weighing 4.5 kg lying on an incline with the angle of 60 degrees? It would be like, so there's an object here. So it's actually for the frictional force. So is equal to the kinetic friction times normal force. So the normal force in an inclined plane again is mg cosine theta. And you know the mass is 4.5 kg. G is 9.8, and cosine would be cosine 60 degrees, which is 1/2. And then you would just plug this into this equation. And also know that the kinetic friction coefficient is 0.3. So you would multiply those together to get the frictional force exerted on the object. Okay, this is the solution. Okay, so this is question 8. Okay, so the solution to this question is that they were not experiencing any forces while they were in space. And they were also, after going in space, they also had a speed of 7 miles per second. So this is the solution right here. So since there's no acceleration, there's no force. So the net force would be 0. Which is why they weren't slammed into their seats the entire time. Oh, come on. And we're gonna do question 9. Okay. Okay, so for this question, it says you and your friend are pushing on a box with a force parallel to the ground of 40 newtons. The box weighs 5 kg and the coefficient of kinetic energy friction between the box and the ground is 0.75. What is the net force on the box in the horizontal direction? So the two forces acting on the box are you and your friend's force and kinetic friction force. So the net force in the horizontal direction would be the applied force minus the kinetic friction force. So the applied force is 40 newtons, and the frictional force is the coefficient of kinetic friction and times the normal force, which would just be mg, which would be 40 times, I mean, not 40, 5 times 9.8, which is just 9.8. And then you would multiply by that by 0.75 to get the frictional force and subtract it from 40 newtons, which is the applied force, to get the net force. So this is the solution. And you can do question time. Okay, so for this question, this is an inclined plane, and if the block is accelerating down the slope at an angle of 45 degrees, so this theta is 45 degrees, at a rate of 5 meters per second, what is the coefficient kinetic energy between the block and slope? So it's asking to find the coefficient of kinetic friction. So you need the frictional force, K times normal force. And in an inclined plane, the normal force is mg cosine theta. So it would be the coefficient times mg cosine theta. And the other force would be the force going this way, since it's going down the block. And again, that would be mg sine theta. So the total force would be ma, and that would be equal to mg sine theta minus this part, mg cosine theta. Ma is equal to mg sine theta times mg cosine theta. And so you can cancel out the mass in the entire equation. And A, and the sine 45 and cosine 45, and G. And so you just solve for the kinetic friction. And so it's 5 equals G sine 45 minus times G cosine 45. And then you just solve to find the kinetic friction coefficient. So this is the solution. And we get 0.29. Okay, so this is our final question. Okay, so for this question, it's the same inclined plane. This is if the angle is 30 degrees now, what is the minimum coefficient of static friction that will keep the block stationary? So we have the frictional force would be the coefficient of static friction times normal force. And to keep it stationary, all the forces have to cancel out. And the other force that's on this to keep it stationary is this force. So the frictional force would have to equal the force stopping from going down. So that would equal to mg sine theta. And the frictional force is the coefficient times mg cosine theta. So cancel out the mg on both sides. So just be left with the static coefficient equal to cosine theta. I mean, times cosine theta is equal to sine theta. So if you divide cosine theta on each side, you would get sine theta is equal to cosine theta, which is just tangent theta. So the coefficient is equal to tangent theta, which is tangent 30. And we solve that 0.58. So this is the solution. Okay, so that will be the end of today's lesson. I hope you guys have a great weekend.